The last section in chapter number 8 is going to be talking about some wave interactions. We talked about waves moving. Now we're going to see what happens when these waves encounter one another, encounter boundaries, and things like that. Well, we've talked about the different properties. Again, those are things that are going to have waves standing still. But we know waves are in motion. When we observe waves, we need to look at how those waves act when they encounter different surfaces or how they act around other waves. Sometimes when we look at waves, they hit these boundaries that they cannot pass through, and when they cannot pass through those boundaries, they end up passing or bouncing off of those waves. That's going to be reflection. Reflection is going to be the bouncing back of a wave when it hits a barrier that it cannot pass through. So kind of like a solid barrier. When we go ahead and we look here, you're looking at reflection right here. You can see the wave as it's going to be approaching this boundary over here. It hits that boundary and all of a sudden bounces off of it. That angle at which it comes in, so this wave right there, that's the angle of incidence. The one that bounces off, this is going to be the angle of reflection. Now when we look at those two angles, you're going to notice that they are going to be equal to one another. So the angle of reflection is equal to the angle of incidence, but the thing that I'm going to tell you is that applies for smooth surfaces. Okay? When it's not smooth, like say broken glass or something that's kind of roughed up, when it hits this surface, it's going to bounce off at a lot of different angles. We really don't know the angle at which it's going to bounce off of. Sometimes waves are going to strike the edge of barriers. Okay, but what happens when it strikes that edge? Well, that's going to be diffraction. Reflection happens when it strikes a surface and bounces back, but when a wave strikes a surface at the edge of that barrier, that's diffraction. That's the bending of a wave around the side of a barrier. So if we look at this water, the only thing I wish is this was in motion, because these water waves would be coming in, hit this wall, and you would see right here reflection. But right here where it passes through, you can see all of a sudden now it's wrapping around, that wave is going to be wrapped around over here. So it wrapped around that barrier. Think of this. If you ever went outside and yelled for your dog and your dog came running towards you, but the dog was in the backyard, your voice wrapped around that house so the dog could hear you and then come running to the front yard where you were. Sometimes waves will change direction when they go from one medium into another, like air and water. And things like that. And the reason why they change direction is because the densities of the mediums are going to be different from one another. One's going to be faster, one's going to be slower. And that's going to be refraction. Refraction is a wave's change in direction as it moves from one medium into another. Think of this. If you're driving in a car and your right side of your car happens to slip onto a muddy shoulder, you know that you're going to be jerked towards that shoulder because the tires that are in the mud are moving slower than the tires that are on the pavement. Couple of pictures. So when we stick this spoon in, you can see the spoon handle up here is going to be in air. But down here, the spoon is going to be in the water. So it appears that that spoon ends up being broken there to there where it connects. When we look at this picture here, it looks like we have this light wave coming in. All of a sudden this is traveling in the air, but when it passes through this glass, it slows it down because the glass is a heavier, thicker density, causing it to appear bent. If any of you have ever gone fishing but with a bow and arrow, you really never actually shoot where the fish is because that fish truly isn't there. As we are looking at that fish, our eyes are looking through the air. But where is the fish? The fish is actually in the water. So the thing is, you want to aim higher than where the fish appears to be. Because think of this spoon is going to be somewhere actually right in here instead of appearing where it is down here. Sometimes you're going to notice that waves come into contact with one another. Think of this. If you're traveling in a car and you're listening to your favorite radio station, and sometimes if you get far enough away, it sounds really kind of crackly and things like that, static. That's because we have different wave frequencies hitting one another, and they're basically interfering with one another. When these waves interfere, what they are doing is they are mixing their amplitudes. There are going to be two types of interference. First one's going to be constructive interference. When you construct things, you make them bigger. In this case, what we're doing is we're making our wave bigger because of the greater amplitude. The second one is going to be destructive interference. When you destruct something, you break it down. And when you break it down, you end up with something that's going to end up being smaller. When we look at this wave graphic, when we look at this wave graphic here, what we're going to do is we're going to put it in slow motion here, and I'm going to get it so it goes. Okay, so we've got it going in slow motion here. So the thing is, when all of a sudden we have this crest meeting this crest, that's going to be constructive interference. Same thing, trough meeting trough. This is going to be our constructive interference. Okay, let's go ahead and let it pass by one another again. And what we're going to do is we're going to let it come towards each other again. So again, notice here, here's a crest, here's a trough. All of a sudden, notice this line. This line starts to go down to almost nothing. Okay, and right here, this is perfect destructive interference. This crest is meeting this trough. And the thing is, when we look at this resultant here, it's almost flat, meaning we have very little or no energy at all. But if I continue it, okay, and notice now, all of a sudden, we've got this crest coming towards this crest. Notice this wave's getting bigger. So we go ahead and continue it, and all of a sudden, I'm going to stop it about now. Okay, not quite there, but notice crest, crest. Here's constructive interference. Constructive interference, bigger wave, more energy. Notice here, trough, trough. Again, more energy in that wave. And then, of course, we can go ahead and take the slow-mo off and let it continue. Okay, so basically, constructive interference is a bigger wave. Destructive interference is going to end up being a smaller wave.